everyone. Today's lesson is on 7.3, double angles formula. Let me just quickly go over the formulas with you again. Since we all know that from the double angles for sine, cosine, or tangent, they're all coming from the compound angles formulas that we did in 7.2. Okay, so like in sine 2 theta, okay, double angles for sine, all we do is to break the 2 theta into a theta plus theta. So from here, we can use the compound angles formula. So for sine A times cos B plus a cos A times sine B, okay? Since A and B are the same, so you will end up with two like terms. So sine theta, cos theta, and a cos theta, sine theta, they're like terms. So you ended up with 2 of the sine theta, cos theta. So as simple as that, this will be the double angles formula for the sine 2 theta. Okay? And cos 2 theta, so double angle for cosine, you break this into theta plus theta. Then you can follow the compound angles formula for cosine as a cos A times a cos B minus a sine A times a sine B. Now, since A and B are the same, so you will also end up with some, well, they're not like term, but certainly a cos theta times another cos theta, you will end up with a cos square theta, okay? And remember, the power of 2 comes in between and not after. And same thing for the sine theta times sine theta, you ended up with the sine square theta. So this will give you the first formula for the double angle for cosine, okay? Why is this the first one? Well, because from this main formula, we can further develop 2 more, okay? And that is basically is based on the definitions that we know from the Pythagorean identities. Okay, so this is what we call the Pythagorean identities. And what the Pythagorean identity says is the following. When you have a cos square x plus a sine square x, and you always get 1, okay? So because of that, I can solve for the cos square x by bringing the sine square x over, so it becomes a 1 minus a sine square x. Or I can solve for the sine square x by bringing the cos square x over, so now I have a 1 minus a cos square x. Now, based on these definitions, bring it back over here. So the cos square theta, I can replace the cos square theta with a 1 minus sine square theta. Okay, so when you remove this bracket, you will end up with like terms. Then you will get the 1 minus 2 of the sine square theta. Okay, so this will give you the second double angles formula for cosine. Okay, so let me just circle this. So this is the main one. This is the first one. This is the second one. And we can also go another step further by replacing the sine square theta, okay, with a 1 minus cos square theta. Okay? And when I expand the brackets, I will get cos square theta minus 1 plus another cos square theta. So at the end, I will end it up with 2 of the cos square theta minus 1. And this will be the formulas number 3, okay, for the cos 2 theta. So unlike the sine 2 theta, you only have one formula. Cos 2 theta, you will get 3 to choose from. Okay? And finally, and the double angles for tangents. So again, when I break the double angles into a theta plus theta, then I can use the compound angle formula for the tangents. So it's a tangents of A plus the tangents of B divided by 1 minus tangents A times tangents B. And because A and B are the same, so you will end up with some like terms. So for the numerator, you have 2 of the tangent theta. And in the denominator, you have a 1 minus, but it's a tangent square theta because you add them or you multiply them together. Okay, so those will be the double angles formulas for the sine, cosine, and tangents. Before I show you some example, I would like to also to remind you sometimes when we have to rewrite any angle such as the sine theta or theta over 2 or theta over 4 in the double angles format, then we need to use the replacement. And the replacement is how can I get the one angles back is when you have a theta over 2. So when you have a sine of a 2 theta over 2, then you will end up with a sine theta. Okay? This kind of a technique is very useful later on when it comes to the proving trig identities. Okay? Now further, if you have how can you have a double angles format for a sine of a thetas over 2 is if you have a thetas over 4 here. So sine of a 2 times theta over 4, then when you reduce it, you will end up with a sine of a theta over 2. And same thing over here, if you have a theta over 8, when you reduce it, you will end up with a sine of a theta over 4. Okay, so that is the kind of relationship between the double angles of any kind in order to achieve the angles on one side. Okay, so let's look at some of the example now on the worksheets. Okay, if you have the worksheets with you, let's look at example number 2. We have 2 sine 7x times cos 7x. So if you know your double angles formula well enough, then you should know that this is going to be the double angle. The angle itself is going to be the 7x. Okay, that's how when you expand it using the 2 times sine theta cos theta, then the theta really is what goes in here. And after that, you can further simplify this into a 14 sine of a 14x. Okay? Because when you expand this using the double angles formula, you need to make the sine 14x into 2 times some theta. Okay? And that theta now becomes a 7x. Next one is the 2 times tangent 3x over 1 minus tangent square 3x. And if you recognize this as the double angles for tangent, then you know that this question is going to be equal to tangents of a 2 times the theta is 3x. Okay? And therefore, you can further simplify this into a tangents of 6x. Okay? And furthermore, C, 1 minus 2 squared theta times the theta over 4. Okay, now you know that this is the one of the double angles for cosine, and in order for this to be the so since the theta here is a theta over 4, so when you put in a cos of a 2 times theta over 4, then after you reduce it, so this question actually is the same as a cos of a theta over 2. Okay? And this is exactly what we were trying to do to show you over here. You know, in order to get into the theta over 2, then my other angle has to be the theta over 4 in the double angles format. Okay? Example number 3. If I have a 2 cos square 5 pi over 12 minus 1. And if you recognize this as the double angles formula for the cosine again, so this one here, you will be turning this into a cos of a 2 times, and the theta is the 5 points over 12. Okay, so from here, you can go further, simplify this into 5 points over 6. Okay, so this is what it means by expressed as a single trig ratio. So this now becomes a single trig ratio, and now you can start to evaluate this. Okay, and to evaluate this, so again, you need to know what degree is that, or what quadrant is this angles going to be. And if you quickly look at that, you know that this is going to be pi over 6 is a 30, so 30 times 5, so this is 150 degree. Okay, if you can quickly calculate that. And you know that 150 degree is going to be in quadrant, the terminal arms is in quadrant 2. Okay, so your related acute angles, okay, is going to be, so the related acute angle is going to be the 30. So it's pi over 6. Okay, and pi over 6, and you know that the sine length of this reference triangle is going to be, so 30, this is going to be a 1, this is a 2, this is a negative root 3. So cosine is going to be the negative root 3 over 2. Okay, so after you evaluate it, so this will be your answer here in exact form. Okay, negative root 3 over 2, because CAST and is only the sign is going to be positive in this quadrant anyway. But if you draw your reference triangle, you should be able to see that as well. Okay, and finally, example number 4. When you have the rewrite using a double angles formula for the following. So this is another practice that so for sine 10 theta, so if you need to break this into 2 times something, then that has to be a 5 theta. Okay, and based on that, you're going to rewrite it using the double angles formula for sine. So it's a 2 sine 5 theta cos 5 theta. Okay, and for tangent 7 pi, okay, so for tangent 7 theta, that means in the double angles format, you're going to turn this into 2 times, okay, 2 times, so you will have a 7 theta over 2, because when you reduce it, you ended up with the tangent 7 theta. And based on that, and you're going to rewrite this using the double angles formula for tangent. So this is going to be a 2 times the 7 over 2 theta divided by 1 minus tangent square, but is 7 over 2 theta. Okay, so it's important to do this step, because this step will show you what the angle, what the theta is, okay, and over here as well, okay. Once you break it down, then the rest, you just follow the formula, but fill in the theta for the formula.